Hello friend, you all know that cell counting is a tedious process. You may have to count a number of cells in many images. Manual cell counting is very laborious and take a lot of your time. In this video, we will see how can we use ImageJ software in order to count number of cells in an image. For example, we have this beautiful image of liver where we can see hepatocytes. We need to count the number of these hepatocytes in this microscopic field. Here the counting of nuclei corresponds to the counting of cells. Each nucleus corresponds to one cell. Therefore, by counting of nuclei, we can say that we have counted the cells. Now closely observe this image. You can see there are many circular figures. Some of them are the nuclei of the hepatocytes, like this one, this one, this one, and many other. They appear circular, but there are many other circular profiles like these. They are probably blood cells. They are also circular, but their size is much smaller than the nucleus of a hepatocyte. Why I am telling this? Because while counting the number of cells, we will count these circular figures called as nuclei. We need to count only the nuclei of hepatocytes. We don't want to count these blood cells or any other cells which are not hepatocyte nuclei. For example, this one do not look like a nucleus of a hepatocyte, and like this one, their size is smaller than the nucleus of a hepatocyte. Therefore, we need to exclude these smaller size profiles from the counting of nuclei. For this purpose, we need to measure the nuclei of hepatocytes. We will take the measurement of an average nucleus of a hepatocyte. Then we will use that figure in the image processing thereafter. Therefore, to start with, let's take this image and open it in ImageJ. Okay. You can see that these are the nuclei of hepatocyte. We will measure the diameter of these nuclei. For example, these two nuclei of hepatocytes, they are smaller size, but even then they are bigger than these profiles. For this purpose, we will use this straight tool and will measure the diameter. I am telling you that ImageJ is not calibrated here. That is not a problem in this case. We can measure these values in pixels. Just draw a line from one end to another, then go to analyze and select measure. You can see the diameter of this, the length of this hepatocyte nucleus is 15.726. This length is actually the diameter of this nucleus, and from this diameter we can calculate the area. Okay, the value was 15.726. You can use any website. You can, and I'm entering the diameter. then calculate it. You can see this is the area of this nucleus. We will use this figure 194.23 in next steps. Therefore, remember this figure. To start with image processing for cell counting, we first need to convert this image into an 8-bit. Then we need to go to adjust and set the threshold. You can see that almost all the nuclei have been selected, but in this area you can see that some area which was not corresponding to the nucleus is also highlighted. This area and some area over here. We need to exclude these areas. For that purpose, we will decrease the threshold to such a level that these areas are excluded. However, nuclei remain selected. Okay, I'm decreasing the threshold. I think at this much threshold, the nuclei are selected, while the undesired area has been unselected. Okay, after this, apply these settings, then go to process and go to binary. This binary submenu contains all the commands. These are commands that create the process binary black and white image. All these commands work on a black and white image. First of all, we will select this make binary. It will make the image into a black and white image like this one. Then we will again go to process binary and convert to mask. Convert to mask, it converts the image to black and white based upon the threshold settings that we have set previously. Next, we will go to process once again, then go to binary, and this time we will select fill holes. You can see that these are the holes. We know that nuclei don't have holes, but these holes are created due to image processing. We will try to fill all these holes by this function. Fill holes, you can see all the holes have been filled. However, these were two nuclei. During processing, these two nuclei have been filled, but we want to count these two nuclei separately. For that purpose, we will again go to process binary and we'll use this watershed tool. You can see a small line is drawn between these two nuclei. Okay, our image is ready for cell counting. We'll go to analyze and then select analyze particles. Now you can see we have to enter the size, which is in square pixels. The size is already mentioned from 0 to infinity, but we don't want to measure any size which is 0 size or close to 0, because there are many small sized areas. We only want to measure the size of the nuclei, which we calculated before, that the size of a nucleus starts from 194.23. Therefore, we will put value of 194. By entering this value, we are telling the ImageJ that you need to count only those figures which are greater than 194 square pixels. Circularity, it ranges from 0 to 1. 0 mean minimum circularity and 1 mean a complete perfect circle. Then and show, and I want to see the outlines of all the nuclei. Then click on display results. I also want to see the summary and this exclude on edges. If we check this box like this one, it will include all those nuclei which are present at any edge, at any border, top, bottom, right or left. After that, click OK. So we have two windows here. One window, the summary, it shows figure name, count. So after processing, the number of nuclei were identified as 222 nuclei. This is the total area of the image, and this is the average size of each nucleus. This is the percentage area of all the nuclei out of the total area. So this is our desired number 222. Let's see this figure. You can see all the nuclei have been encircled and smaller sized figures like RBCs or other blood cells have been excluded. You can also see that these two nuclei have been identified separately. Okay, I hope that you have understood how the number of cells are counted in an histological image. If you have any questions regarding this, please let me know. Like this video and subscribe to my channel. Thank you so much.